Good afternoon, and thank you for joining our webinar today, part 1 of 2 in our Shifting QA Left series. Today's session will focus on resolving one of CI/CD's biggest bottlenecks. I hope everyone is having a great afternoon. My name is Vikas Arya, and I'm the Principal of Strategy at Ixion Solutions. And I have the pleasure of being your moderator today. Before we get started, I'd like to go over a couple of housekeeping items. First, we welcome and encourage your questions throughout the webinar. To ask a question, all you need to do is type your question directly into the question window on your GoToWebinar control panel and press submit. We will answer as many questions as possible during the QA session after today's presentation. Secondly, we are recording today's webinar and will post it on the Ixion website later this week. I'll send you an email once it's live in case you want to watch it again or forward it along to one of your colleagues. We understand that software testing and QA can slow down the software production process. Therefore, our webinar series focuses on how shifting QA to the left on day 1 brings the focus on quality from the moment development begins instead of waiting until the standard testing timeline later in the process. Studies show that 70% of software issues can be traced back to misunderstood or misinterpreted requirements. In response to this challenge, Agile principles and frameworks are more readily adopted across industries so that teams can improve collaboration and communication while delivering greater quality in shorter timeframes. 2 distinct practices support this evolution. Test-driven development, or TDD, is a developer-focused practice where developers, not testers, write the test before they write their code, and then they keep refactoring their code until it passes that test. This approach endorses the idea of understanding what you are trying to build before you start building it, and when done correctly, developers should actually be developing better code focused on quality and efficiency. The second practice, behavior-driven development, or BDD, is an agile software development technique that encourages collaboration between developers, QA, and non-technical or business participants in a software project. BDD focuses on obtaining a clear understanding of desired software behavior through discussion with stakeholders. It extends TDD by writing test cases in a natural language that non-programmers can read. It's mainly driven by business value, that is, the benefit that the business will accrue once the application is in production. Ixion utilizes these techniques to provide clients the highest levels of QA and efficiency in implementing new technology in application development. Our developers, testers, and other fungible technologists utilize these methods on projects that are modernizing legacy systems and methods of development. Be it proprietary tools or open source tools such as Selenium, Maven, and Cucumber, leveraging BDD and TDD practices allows teams to improve quality by focusing on it from day 1 in the development cycle. Now, please join me in welcoming today's speaker and QA expert. Rajat Sood is a solution architect focused on agile delivery and DevOps adoption, and has been supporting one of the largest payers of health benefits for federal employees. He is responsible for evangelizing modern tools and processes supporting various QA disciplines and modernizing their test automation infrastructure from closed source systems such as HP's suite of products to more extensible offerings such as Selenium, JMeter, and various web services testing tools. Rajat routinely engages in various DevOps and Agile forums, offering and seeking new ideas to streamline development and deployment pipelines. In his previous roles, he has consulted with various technology firms spanning media, finance, healthcare, and wine e-commerce. So now I would like to turn the program over to Rajat.
Thanks, Vikas. Good afternoon, everyone. Again, my name is Rajat Sood, and I'm truly passionate about agile delivery mechanisms and how various DevOps capabilities facilitate that. In today's conversation, we'll share some of our experiences towards what a vast set of industry stakeholders indicate is their biggest bottleneck to a successful CI, CD, and DevOps rollout. As one of the pillars of a successful DevOps inculcation, the QA industry is witnessing nothing short of a metamorphosis over the past few years. Stakeholders no longer accept quality to be inversely proportional to delivery speed, especially within an agile SDLC. And throwing additional resources to cope with faster time to market is not a very scalable approach. With that in mind, here's today's rundown. We'll share some of the challenges and opportunities that we've experienced over the years. We'll provide some insights into how to stand up a successful QA practice on all three fronts: people, process, and technology. We'll also walk through an illustration of metrics that can be adopted to gauge the success of the investment that you are making in shifting QA left. We'll finally round up the discussion with some next steps and key takeaways. We certainly have a lot of content and look forward to your participation during and feedback after this webinar. As Vikas mentioned, we'll certainly look forward to taking some questions towards the end. So to set the stage, here are some industry survey results. From Computing Group's 2017 DevOps review, no matter where in the DevOps maturity scale they were, when thousands of respondents were asked what their main holdups in the software production process was, as many as 63% of them attributed QA as one of their biggest bottlenecks. The bottleneck that QA poses was attributed to multiple reasons, such as lack of expertise in state-of-the-art testing tools, resource or people constraints, and treating QA as a post-development silo and not better integrating it in the overall development process. Further, modern architectures are becoming increasingly complex. Application stacks comprise of modern and legacy technologies which merit different testing considerations. An emphasis on microservices to tie these together pose unique testing challenges, but where there are challenges also arise opportunities. With the advent of large-scale adoption of Agile, never before has QA had more of a prominent seat at the table. That prominence provides a significant opportunity to propose and implement processes using functional knowledge, technology, and processes such as in-sprint automation, which drastically scales down the time spent for regression testing in future sprints. And finally, the biggest opportunity lies towards collaborating with other stakeholders, including business, that is your product owners and business analysts, and developers, using paradigms such as a test-driven development and behavior-driven development. Quality can now be inculcated in every phase of the SDLC, with every stakeholder making a contribution. From a testing perspective, these paradigms can vastly streamline documentation and test automation. In fact, BDD will be a focus topic during the next webinar in our Shift QA-led series. So now that we've spoken about the challenges and opportunities, let's spend some time talking about how to overcome and achieve these through a multifaceted people, process, technology approach. First, the part that excites most, the technology. Here's a sample of a technology stack that we recently implemented to support in-sprint automation at a large federal claims processor. You will notice that alongside the various tiers of the stack, on the right side, we've indicated the capability that the layer brings to the stack, and on the left side, the stakeholder that's involved. Also notice that we've included every genre of stakeholder, furthering the opportunity to include everyone in the QA stack. To go over the stack quickly, starting from the top, we integrated with Jenkins, a popular CI/CD tool, to kick off automated test executions in a triggered, scheduled, or push-button on-demand basis. Since our client was essentially a Java shop, we were able to leverage Maven for dependency management. Going down, TestNG is a JUnit style framework that provides test organization and parallel execution capabilities to speed script execution. The crux of the stack was integrating QCombo, which is a popular BDD framework that provided the ability to translate plain English specifications into executable test scripts, which are implemented using popular testing APIs, such as Selenium for browser UIs, SOAP UI for web services, JDBC for data sources and targets, and some other proprietary off-the-shelf technologies which were heavily used at our client. Now, as with any development effort having multiple contributors, the source code review and quality was managed through a Git rendition, such as Bitbucket, Fisheye, and Crucible in this case. Finally, all reporting needs were integrated into the test management tools, so as scripts executed, the pass or fail results were pushed via the management tools API. Now, this is just a sample technology stack that hopefully depicts the degree of modularity and thought required in navigating complexity to achieve rapid test automation with low maintenance while permitting everyone to contribute. Personally, I feel it is important to implement a test automation technology stack in the same language as your development stack. So for example, if you're a Ruby or a .NET shop, I would encourage your test automation stack to implement these same languages. This way, we're truly providing the ability to developers to execute test automation scripts, possibly in their own dev environments, even before pushing to shared environments, truly shifting left. Moving on to the process front. Typically, as any project kicks off, from a testing perspective, we begin with documentation, understanding the specs and drafting and reviewing test cases. After that, once development is underway and builds are being deployed, we get into test execution mode. And during execution, we're hopefully reporting status and ensuring that compliance needs are met. Now, from an agile perspective, documentation is typically rendered in the form of user stories, which are, during the grooming sessions, decomposed into acceptance criteria. In order to truly implement a TDD or BDD practice, herein lies an opportunity. As development gets underway, the acceptance criteria can be translated into executable test scripts, which test engineers can supplement with test data and environmental configuration. Once done, for execution, these scripts can be integrated into the DevOps toolchain to facilitate automated execution. As scripts execute, reporting systems can be updated with a pass-fail status. And all of this can be achieved within the sprint. Then we've truly achieved a degree of delivery cohesiveness between all stakeholders, and that includes test engineers, developers, and business folks. From a QA front, we're minimizing the documentation overhead by expanding agile acceptance criteria into executable, reusable test scripts, streamlining regression testing for current and future sprints. And now, for arguably the most contentious part, people. Many times in my engagements, looking from the outside in, it can prove daunting, as with anything, to introduce a new way of doing things. Testing is no different, especially in the wake of increased visibility and higher expectations. In order to aid adoption, it is important to start small and rapidly, analyzing system architectures and identifying testing opportunities. Once done, devise the testing technology stack and then get working. Now, we have an excellent blog post on how we should move away from throwaway POCs and implement reusable MVPs for possibly every tier of the application stack. These MVPs should be designed with scalability and adaptability in mind. As testing technologies are being developed and shared, identify opportunities for process improvement, such as when in a project's lifecycle can the technology be deployed? What are the artifacts that come out of it? Who owns it? Now, the success of the technology and processes improvements conceived above can only be realized if they are adopted. That's why going in with an adoption plan to empower users, not merely train them, which means providing an initial overview, followed by supporting as they learn and implement it themselves, is critical to success. Typically, with our clients, my recommendation is to pick a pilot project to implement the technology, processes, and also empower the team members to be a part of the movement. Coming up next, with a wider scale adoption, the next maturity step is to share on an enterprise scale. To do this, establishing a forum. You can call it a center of excellence or a center of enablement to identify and promote the best practices, and also to standardize capabilities and, most importantly, stay abreast of industry trends. Moving on through our agenda, we wanted to share an illustration of some metrics that we compiled that illustrate success. These metrics have been categorized into two categories, cost and ROI. Speaking about development costs first, after our solution was rolled out, we surveyed the test engineers the time spent automating user stories across 2 sprints within the sprint itself to gauge how much time they allocated and also the ease of automating. We found that an average of 35 minutes per user story was being spent in translating the acceptance criteria into scripts and supplementing it with the requisite test data. Our team had 4 resources, so we calculated that each of them was spending about 3.5 hours purely for development. Now, other automation-related activities that test engineers were engaged in were about execution, triaging results, especially failures, managing test data, and let's not discount the time spent in maintaining prior scripts due to environment and application changes, which happens all too often. Summing all of this up, we came with an ask of 14.5 hours per test engineer per sprint devoted to test automation, which loosely translates into 2 or 3 days, again per test engineer in a 3-week or 15-day sprint, yielding a near, if not full, 100% in sprint automation. Providing these metrics enabled us to get the project management to invest time for automation in every sprint, resulting in the creation of an automated regression suite that was continually added to and maintained within the confines of the sprint itself as stories were being developed. And now to the slide about the more anticipated return on investment. So in the same manner that helped us compute costs, we took a shakeout regression suite for an application. Based on the number of stories deemed critical enough to be made part of the shakeout suite, we computed the development time using the same average of 35 minutes per user story. This summed up to about 700 minutes for about 20 stories that were in that suite. If we were to execute this manually, the test engineers surmised that each would take about 5 to 10 minutes to execute. The automated, unattended execution time was just 5 minutes off a Jenkins box. When we surveyed these metrics, there were 65 times that this was executed. Now, scaling the manual and automated timings 65 times, we reckon that the ROI in terms of test engineer time saved was to the tune of 1,200% and growing. Moreover, having a robust shakeout suite gave developers the confidence that any build deployments, which at times there were multiple per day, did not break existing functionality. Now, it must be said, however, in full disclosure, that these metrics don't include development time of the MVPs and the automation infrastructure that facilitates the low cost and high ROI. And this is where we'd be happy to engage and accelerate development, deployment, and adoption. So hopefully that provided some insights into the questions to ask and the intelligence to gather as you factor in the costs associated with implementing the technologies and processes, and then measuring ROI success. And hopefully this has ignited interest and has got each of you asking about how to move forward. So should you be interested in employing test automation as a part of your SDLC for the first time, or modernizing your existing automation infrastructure to offer more capabilities and scalability, in our experience, a phased approach works well. To begin with, we recommend an assessment of your technology stack and the various testing opportunities and expectations. From there on, determine what test automation technologies are out there and how best they fit your current skill sets and future visions and aspirations. Once done, create and deploy MVPs while keeping a close eye on cost and ROI metrics. Tweak processes if required to improve or course correct. Once comfortable, scale testing abilities to include other projects. Improve overall team velocity by managing stable test automation infrastructure, giving developers the confidence to refactor. Now, for those of you who've heard this term fungibility before, Vikas spoke about it earlier. It refers to team skills where one stakeholder can jump in and perform the other stakeholder's duties. So for example, developers and BAs can test. Testers in turn can review unit test cases and possibly fix code defects, or even lead grooming sessions, etc. And to promote fungibility, since you've hopefully implemented the same tech stack as developers, ask them to contribute towards testing. Ask test engineers to review unit test cases, and in doing so, build a robust, risk-driven testing infrastructure at every stage of the SDLC. Finally, as you grow and mature, implement peer programming practices where developers and testers collectively contribute to testing at all stages, including unit testing. And then, to extol the virtues of test automation, offer and conceive testing as a service to other organizational stakeholders to streamline their operational tasks. So to conclude, here are the key takeaways. Again, now more than ever, our industry is providing us an opportunity to transform QA as a bottleneck to QA as an enabler, to give developers the confidence to refactor and product owners the confidence in the test coverage, while the team delivers on a faster time to market. We spoke extensively about implementing technologies and processes for rapid development and low maintenance via in-sprint automation, and most importantly, bringing people along for the ride by empowering them to adopt and contribute. And to round it up, we're big proponents of collaborating beyond the confines of just QA, and this can be realized by implementing scalable technologies and proving an increasing ROI one automated execution at a time. Through paradigms such as TDD and BDD, our aim is to rope in all stakeholders, ensuring that quality is built throughout the SDLC and not just as a post-development activity anymore. With those takeaways in mind, over to you, Vikas.
Great. Thank you, Rajat. We've received a number of very interesting questions, which we will get to in just a moment. But before we do that, a couple of reminders. First, to our listeners, if you have a question you'd like to submit, you still have time. Remember to just type your question into the questions box on your GoToWebinar panel and press submit. And a second reminder that our second webinar in the Shifting QA Left series titled Getting Everyone on the Same Page will be held live on Wednesday, September the 20th at 12 noon Eastern. We hope that you can join us. Now to our first question. And Rajat, the first question really gets back to the trifecta that you talked about. And our listener wants to know, out of people, process, and technologies, what in your experience is the most challenging?
So for me, in my experience, it's undoubtedly people, because based on my experience, I believe for the first time, the automation APIs and tools have reached a maturity state that make them easy to implement. Not necessarily easy to adopt, though. So getting people to acknowledge first the shift in the technology stack, and then getting them on board and willing to invest in themselves and furthering their careers, and then finally embarking on an adoption plan is by far the most challenging aspect to shifting QA left. And sort of all starts with an executive level buy-in to the long-term benefits while dealing with the short-term growing pains. Test data configuration, that is another bottleneck in my experience. Managing test data across various environments can get challenging at times, but then there are tools out there that help streamline that activity as well.
Great, super. Thank you, Rajat. Our second question, our listener would like to know, how do you determine which technology is best for the long term?
So I would definitely start with evaluating what kind of development shop you are, followed by an introspection of your QA skills and what will it take for the team to train and adopt those new technologies if they are new indeed. So implementing QA technologies is nothing short, in my mind, of a development activity. And using the same development stack helps enable synergies and that level of cross-collaboration you're looking across all the stakeholders. As we spoke, developers can potentially execute tests early in their SDLC, possibly in their own local environments, and without having the need or the hassle to procure additional tools or IDEs or licensing or training, can vastly help that. So to summarize, look at your own technology stack to begin with, and look for test automation APIs that are implemented using the same development stack.
Great. Thank you, Rajat. Our next listener says that they are a Java shop, and they would like to ask you, how long would it take to implement the technology if they are a Java shop?
So the short answer to that is it depends. And the long answer is it depends on how many applications you have in your ecosystem and the complexity for each of those. As a capability, for example, working through basic browser UIs and web services, for example, assuming you're a Java shop, can take up to 3 person months in my experience to set up with an eye to scalability. And once again, this is assuming you're a Java shop. Some other technologies, such as Ruby, in my experience, have a shorter time frame given the level of abstraction, while others, such as Python, may have a more protracted duration. So hopefully that sort of gave an idea of what kind of estimates we're looking at. Now, that can be scaled up or down depending on the level of resources you can throw towards this effort and the expertise that you can bring in-house to sort of accelerate the development and adoption.
Excellent. Thank you, Rajat. Our next user would like to ask, what's a good mix of tester to develop ratio to achieve in-sprint automation?
So that's always a question that we sort of get asked a lot as teams are setting up and embarking on this journey of Agile as to how to sort of organizationally orient each project, in terms of the mix of stakeholders. In my past experience, a 1:2 tester to developer ratio is healthy and ensures that that development pipeline that you're hoping to achieve keeps chugging along. And some adjustments may be merited depending on the skill set of testers and developers and the time of release cycle and the expectations surrounding the speed to market. And that's where, I always advocate employing a style of Kanban, kind of board of task management that helps gauge the effectiveness of resource contributions. And this sort of allows you to course correct. So as and when bottlenecks to any testing or automation task, or for that matter, even development, if you've truly got fungible resources are encountered, you can always sort of redeploy resources, or not always advocated, but sometimes necessary, practically speaking, shift resources between teams to sort of keep that pipeline moving along.
Okay, very good, Rajat. You touched upon a risk-based automated infrastructure. Our next listener would like to know, how exactly do you build that?
So I was secretly hoping someone picked up on that. So it kind of all starts with associating priorities with each specification. If you're on the waterfall side, or acceptance criteria if you're on the Agile side that you're building. And the key to this is that every stakeholder's input to their perceived priority is taken into consideration. For example, now maybe what may be a priority to the business may be implemented using an extremely stable technical stack, so it may have a lower priority for developers. Could be the other way around as well. What might be perceived as a low priority to the business may be, like brain surgery from a development perspective. Once organized, so these prioritized specifications can be built and rolled up and executed as separate execution suites, in effect providing health checks for the application and enabling that additional dimension of intelligence to take and facilitate go, no-go decisions for all stakeholders. So for example, at our client, we sort of advocated the assignment of 3 priorities, in effect a shakeout level priority, a high level priority, and a low level priority. Every acceptance criteria was in one of these 3 prioritized buckets. And the process that we dictated was that the shakeout suite should be 100% pass, absolutely no failures. the high priority suite should be about 90% pass, and the low suite should be 70% pass for passage into the higher environment, leading right up to production. So just kind of building out this surrounding additional metadata corresponding to every specification or acceptance criteria that you're fleshing out enables downstream benefits within test automation to roll these into separate prioritized suites that once again can be facilitated to execution at their own frequency, and then enable you to take decisions, go, no-go decisions based on their pass or fail status.
Great. Thank you, Rajat. That was very informative. So it looks like those are all of the questions we have this afternoon. If you have, this is again to all of our listeners, if you have any additional questions that you'd like to have answered, please feel free to email me directly at the email address on the slide, and we will be sure to answer them for you. And so finally, I just want to thank everyone again for joining us. I want to thank Rajat for the fantastic presentation. And we will see you on Wednesday, September 20th for the second webinar in this series titled Getting Everyone on the Same Page. In this webinar, we will focus on how we've effectively used behavior-driven development to foster cross-stakeholder collaboration and used it to inculcate quality throughout the entire SDLC. So again, thank you all for joining us today. Everyone, have a great day.
All right. Thank you.